Alright, so I made a mistake. One that'll probably affect my health in very negative ways, but I'll deal with that when I'm 50, get lung cancer, and start making crystals in an RV somewhere. So over the last few weeks of living my oh-so-fruitful life, I started noticing that a lot of the objects in my lab were starting to get frosted. At first I thought nothing of this, but then I started thinking, why is everything around me starting to rust and corrode? This was honestly causing me to tailspin and driving me to a point of madness that absinthe and gas station stimulants just couldn't cure. The corrosion got worse and worse as the days went on, and I just couldn't figure it out. The sheath of this sword was actually shiny when I first got it, very similar to the blade, but now it has absolutely no shine whatsoever, but the blade is still completely intact. Like, why did the sheath get frosted but not the blade? This was actually one of those big clues that allowed me to figure out what exactly was going on. The sheath was exposed to the air and got frosted. The blade was not exposed to the air and did not get frosted. So whatever was doing this was in the air, and anything that was not in the air was pretty much protected. So due to my very thorough detective work and my process of elimination skills, I started connecting these problems to an online purchase that I made a couple weeks earlier. And that's where it hit me. I'm a dumbass. I bought this new bottle of hydrochloric acid because my old one ran out. Let's just leave it at that. And like the dumbass that I am, I left this new bottle sitting on my shelf without any safety precautions in place. That was a big mistake that I should have known earlier. Apparently, when the hydrochloric acid is not sealed properly, I'll talk about this in a second, the acid creates these acidic fumes that consist of HCl gas, even when it's stored in the manufacturer's bottle. Hydrochloric acid is basically hydrogen chloride gas that's dissolved in water. The really annoying thing about HCl is the fact that a lot of that gas does not want to be in liquid form. It wants to escape back into the air. These HCl molecules evaporate out of solution, and they're actually not super harmful on their own. However, once they're airborne, the HCl gas teams up with moisture from the atmosphere because it's extremely water soluble, and then they form microscopic acid droplets on the surfaces of all the different things that you love. These metal objects then get attacked by the acid through oxidation, which causes the metal to corrode. So instead of just floating around harmlessly, these acid droplets go and they break down things in the surrounding area. It doesn't help that the traveling of these HCl molecules are sped up through increased temperature and moisture. God, I love summer. Swamp ass and mosquitoes. On another note, many metals react with oxygen through oxidation reduction reactions that form these metal oxide layers that actually help protect the metal underneath from further corrosion. Good example is that sexy woman wrapped up in a curtain holding a torch. The green stuff around her is copper carbonate and copper sulfate, which, like I said, help protect her from further corrosion. This sounds like a happy ending, but acid doesn't give a shit. Especially chlorine, which I consider the douchebag of all elements. Not sure if you ever smelled chlorine gas before, but it pretty much feels like somebody took an ice pick and stuck it through your nose up into your brain. Not very fun. Chlorine actually breaks down these protective metal oxide layers, allowing the acid to reach the metal underneath, accelerating further corrosion. More fun. Another great example is stainless steel, which is very well known not to rust. This anti-rust trait is caused by the chromium in the steel forming this metal oxide layer that doesn't allow oxygen and water to reach the metal underneath. Chlorine, on the other hand, is the double champ. It does whatever the fuck it wants. These chloride ions, they act like little chemical crowbars. They pry apart the protective metal oxide coatings used to defend themselves, and once that barrier is gone, the metal underneath gets absolutely destroyed. Even with your electronic devices, chlorine reacts with copper to form copper chloride that your electronics are not very fond of. This fan that I had in the lab was completely fine before this incident, but now it's, mentally challenged. Electronics especially hate chloride contamination because tiny amounts of this type of corrosion increases electrical resistance, short connections, and destroy contacts entirely. Which explains why this fan sounds like a lawnmower on Saturday morning when you're trying to sleep. Yeah, this is pretty bad. For my sword, my electronic equipment, and my lungs. Is that blood? Before I continue, I just want to say don't try this at home. I'm a very well-seasoned chemist. I have about 7 decades in the field. HCl is no joke. Although this is not something I should be doing, I'm going to do it anyway because OSHA is more like a suggestion at this point. So I'm going to take this container and I'm going to place different objects inside. I'm going to use these bolts that are made of steel, these pieces of copper, this stainless steel children's toy, Hot Wheels, and SpongeBob. One of the containers is going to include a beaker of concentrated 12 molar hydrochloric acid only. This is the strongest acid you can buy at normal temperature and pressure, by the way. The second run of this experiment will contain the same concentration and amount of acid, but this time I'm going to add a bunch of moisture to see if our little moisture theory checks out. In theory, the container with the moisture should have a lot more corrosion than the one without the moisture, but I guess we'll just see what happens. Also, in each container I'm going to put a pH strip to see if the acid is actually leaving the beaker and hitting the strip, which should turn it from yellow into a red pH strip. The HCl in the beaker should evaporate out, filling our container with acidic gas, reacting with our objects. Hopefully I seal these containers correctly and I don't have the same incident that happens again. Alright, so this is 3 days of those objects sitting in this bin with the hydrochloric acid. I know it sounds like I'm a dumbass sometimes, but I do wear safety protection. I don't always wear a shirt though. Are these on? Here we are. Okay, so I had this sitting outside of my porch for about 3 days. Untouched, just let it go. The first thing I want to note about this is the lid started to change colors. It was clear like this, however now it's turning like a grayish black kind of thing. Kind of afraid to open this. I don't want these HCl fumes to come, and I've been hit with that shit before. Oh, okay. That smells like a public pool. All right. Oh, God. Oh, dude. Mother. Most of the HCl in this beaker is evaporated and gone. And now I'm starting to see what this stuff actually did, and it's kind of impressive. Okay, so first things first, the steel wool that we have here is absolutely green. I was not expecting that to turn green. Oh my God. Wait, whoa. Oh God, I smell it. Alright, so I'm switching over to something a little more reliable. I might have to speak very loud because you might not be able to hear this, but there is this dust. It's like sawdust. I don't know what this is. And I can just smell the fumes. The steel wool is absolutely destroyed. I don't know what's going on there. Something is happening with this Hot Wheels. It's like it's wet on the bottom and it's still drivable and the metal is still okay. Both knives, the metal part is turned like a green color, very similar to the Statue of Liberty. It's kind of coming off when I put my glove on it. Both knives are completely green. This is not really what I expected, to be honest with you. Still kind of intact though. The copper got a little frosted. This is what I expected from the copper. Like it just needs some light sanding or a polish or something. The bolt is a little damaged, but it's still there. Everything's still fine with it. And the most important one of all, SpongeBob seems to be completely intact. So we had a survivor. And the pH strip has turned a bright pinkish, reddish color. We'll see what happens with the water misting. This is a fucking mess, dude. I don't like this. Here we go again. So this right here is the second bin. And all the items that I bought for this bin, they're all duplicates, so I bought 2 of each. This is the bin that I sprayed all the water in, as well as having the hydrochloric acid. Let's open it up and see. Please don't hit me. Oh, God. There's crackling, dude. Okay, so the first thing that I'm noticing about this is the acid, or the water, one of the two has turned green inside of this thing. There's green, liquid water everywhere on the bottom of this. Surprisingly, these items actually look a lot better than the items that didn't have the water. I'm assuming that because the water, there's going to be more damage to these items. Another thing that I noticed is that, like the 2 kitchen knives that I used in the previous experiment, these ones are not green. There's no coating on these knives. Although I don't have any exact ways of quantitatively measuring how much damage was done to these items, I do believe that the bin that had all the water sprayed in it is doing a little more damage, as it's been 3 days and there's still a little bit of sizzling going on. The items with the water, they don't look as damaged, but I think that's just because they don't have that coating that the acid put on them. However, just like the first experiment, SpongeBob is still fine. And I think that's what really matters. So I really don't want to bring any of this stuff out onto my desk and potentially have just a freaking mess that I'm going to have to deal with, because everything in this bin is covered in acid right now. I'm probably just going to take this entire thing, hose it down, bag it up, and dispose of it. I don't really know what else to do. Alright, the steel boats look like they just spent 6 months out at sea. The copper is starting to form those beautiful copper chloride compounds. Even the stainless steel is actually starting to lose the fight, which kind of surprised me a little bit. Kind of thought it would hold up a little bit better, to be honest with you. Not really sure if the Hot Wheels are still drivable, but I'll take them for a spin. Even the pH strip that I never touched is now turning red. This proves that the gas escaped the beaker, spread through the container, dissolved into the moisture, and acidified the air itself. SpongeBob looks pretty damn good though. I will give him that. Ow. So acid vapors are a real thing. You probably thought I was lying at the start of this video, but I've never told a lie, and that makes me a liar. A good thing to note, corrosion can continue even after the acid source is removed because many salts left on the metal surfaces are hygroscopic, meaning they pull moisture directly out of the air. So the surface basically stays permanently damp and acidic where the acids become dissolved and don't leave until you physically wipe them off or set them on fire. I'm not really sure if the fire part is true. I just like burning things and probably need therapy. Storing acids is actually really important, which you should know if you made it this far in the video. For something like HCl, a secondary container that's airtight with a seal is essential to keep the acid contained. That's why I use this state-of-the-art Home Depot bucket, which may look incredibly stupid, which it is. However, chemically speaking, it gets the job done. The bucket itself traps escaping vapors, and the gasket helps reduce airflow. Although HCl vapors are still going to accumulate inside of the bucket, that's why I use this beaker of baking soda to help neutralize it. The neutralization with this baking soda and hydrochloric acid forms water, salt, and carbon dioxide, which are all very relatively harmless unless you're drowning, get heart disease from sodium, or you're trapped in a submarine with no oxygen. I've never really seen myself in any of those situations personally. As soon as I made all these changes, the corrosion around me seemed to stop happening, which I would consider as a win. Now, this isn't true for all acids. Something like sulfuric acid, on the other hand, has a very low vapor pressure and generally won't evaporate out so fast, so you don't really need to do this for every single material. Always do your research. Alright, so the moral of the story is, if all your tools steadily start rusting, your electronics are dying, and your lungs feel like they've been marinated in battery acid, maybe don't store hydrochloric acid next to your desk. Alright, remember, the first rule of this channel: do not subscribe, do not like this video, and don't you dare leave a comment.